Imagine a world where robots navigate busy streets, perform delicate surgeries, and even help manage our homes, all autonomously. This isn't just a future, it's happening right now.
Welcome to my channel, Simple-WhenExplained, dedicated to simplifying complex technology with over 20 years of engineering expertise. I'll guide you through practical advice and real-world examples. Complex concepts become clear. Join me on this exciting journey to explore technology together. Subscribe now, and let's ignite your passion for technology.
When we talk about robotic sensing and perception, we are diving into the technologies that allow robots to understand and interact with their environment. Those systems enable robots to see, feel, and make decisions based on real-time data. In this video, our goal is to provide a comprehensive understanding of the advancements and future trends in this fascinating field. Trust me, the cutting-edge nature of those technologies is nothing short of transformative. It's not just about machine performing tasks. It's about those automated systems evolving to understand nuance, adapt to new challenges, and integrate it seamlessly into various aspects of our daily lives. As we delve deeper into this topic, you will discover how far we have come and how much further we can go. Whether it's for industrial applications, domestic cores, or life-saving medical procedures, the scope of the robotic sensing and perception is vast and continuously expanding. Let's take a step back in time to understand where it all began. The journey of robotic sensors started with basic components like bumpers, limit switches, and photocells. Those early sensors were primarily focused on ensuring safety and basic movement tracking. For instance, early robots would use bumpers to detect obstacles by touch, essentially stopping when they hit something. The first sensors laid the groundwork for more advanced technologies. Over the decades, as robotics evolved, so did the sophistication of their sensory equipment. From mechanical switches that merely indicate presence or absence, we moved to sensors that could provide detailed feedback about our environments. Today's advanced vision systems relying on cameras have revolutionized robotic perception, enabling object identification, obstacle navigation, and environment interaction. The DJI Phantom 4 Pro, for instance, uses cameras for obstacle avoidance and precise navigation. Those systems analyze visual data in real time, enhancing robot autonomy and versatility. From robotic vacuums to drones, modern vision systems, including 3D vision and depth perceptions, are making robots smarter and more capable. LiDAR technology uses laser light to create a detailed 3D maps, crucial for navigating complex environments. Waymo's autonomous vehicle, for example, use LiDAR for accurate mapping and for safe urban navigation. LiDAR has expanded robotic perceptions, offering precise distance measurement and spatial representation. Its adoption has transformed fields like urban planning, environmental monitoring, and archaeology, making it essential in modern robotics. Sonar is another critical technology, used primarily for underwater navigation. Then we have force sensors that enable delicate manipulation tasks. Amazon Robotics employs various sensors to navigate and optimize warehouse operation efficiently. Those sensors offer a layer of interaction previously unavailable to robots, making them more versatile and capable on a variety of settings. Sonar sensors, with their ability to detect objects using sound waves, provide reliable navigation underwater, where vision systems might flutter. Force sensors, on the other hand, bring a tactile dimension to robot interaction, enabling precise control in tasks like assembly, material, or handling even surgeries. This advancement allows robots to perform with level of fineness and accuracy, mimicking the nuanced delicacy of human touch. One of the most exciting developments is biometric sensors. Those mimic biological systems for more nuanced interactions. Imagine a robot hand that can feel texture or pressure, just like a human hand. It's incredible how those technologies are pushing the boundaries of what's possible. By replicating those sensory capabilities of living organisms, those sensors open up a plethora of possibilities, from robotic surgery with lifelike precision to interactive robots that can respond to human touch. The potential applications stretch across sectors, bringing a human touch to tasks traditionally dominated by cold mechanical precision. Artificial intelligence (AI) integration, especially through machine learning, enables robots to recognize patterns, classify objects, and make predictions. For instance, SoftBank's robotics paper uses machine learning to recognize faces and understand speech. These technologies allow robots to learn from data, adapt and improve over time, making interaction more natural and tasks more efficient. Machine learning is crucial for creating adaptive and intelligent robotic systems, transforming how robots interact with the world. Deep learning enables robots to handle complex tasks like object grasping and navigating dynamic environment autonomously. The Roomba i7 uses deep learning for efficient home navigation and cleaning. Those algorithms allow robots to process vast amounts of data, making sense of interact patterns and achieving high level of proficiency in tasks such as autonomous driving and data analysis. This technology significantly enhanced robotic capabilities. One of the significant benefits of advanced perception capabilities is enhanced human-robotic collaboration. Robots equipped with superior sensing can work safely alongside humans in various settings. For instance, Fanuc CR35IA uses 4 sensors and vision systems to collaborate safely in industrial settings. Similarly, the Da Vinci surgical system utilizes advanced 3D vision and tactile sensors to precision surgery. The synergy created through human-robot collaboration is redefining traditional workspaces. By integrating robotics into environments previously dominated by human labor, industries can achieve higher efficiency, precision, and safety. Those collaborative robots, or cobots, are designed to work alongside humans, complementing their efforts and providing support in tasks that require consistency and reliability. The integration of advanced sensing technologies ensure that those robots can navigate around humans safely, making workplaces safer and more productive. Robots are also making strides in performing tasks in hazardous or remote area, reducing human risk. The Blue River Technologies See and Spray robot, for instance, navigates large fields and precisely applies herbicides, significantly enhancing agricultural efficiency while minimizing human exposure to chemicals. Deploying robots in hazardous environments transform how we approach dangerous tasks, minimizing human risk and increasing efficiency. Whether it's in agriculture, mining, or disaster response, robots can be programmed to handle challenging, often dangerous conditions, ensuring that critical tasks are completed without putting human life in jeopardy. Robotic surgical systems, like the Da Vinci, enable surgeons to perform complex surgeries with precision and minimal invasiveness. Those systems improve surgical outcomes, reduce recovery times, and are expanding into diagnostics, rehabilitation, and elderly care, transforming healthcare delivery. Robotic sensing and perception technologies allow robots to navigate and interact autonomously. Modern advancement includes vision system for object recognition, LiDAR for 3D mapping, Sonar for underwater navigation, and force sensor for delicate tasks. AI and deep learning further enhance those capabilities, enabling robots to perform complex tasks and adapt to new situations. Those technologies improve human-robot collaboration and safety across industries, from manufacturing to healthcare, and are transforming how robots handle hazardous tasks and precision procedures. Don't forget to subscribe to our channel and ring the bell icon to receive notification for our latest videos.